There we go. We get some people coming in. I'm going to play a bumper. Hello. Welcome. It's the Golden Path. How are you guys doing?
Wonderful. Good to be
Great.
here, Dishan.
Yeah, happy to be here.
I'm happy to be here. I'm jazzed to be here. I'm going to let you guys introduce yourselves, and then let's just jump right in and let's get started. Everybody's here for Golden Path to SpringOne. We're excited. We've got some momentum coming from the SpringOne Essentials that happened last week, and that's going on right now. And we're all heading in the same direction. I'm excited about this session. But first, yes, let's introduce ourselves.
Wonderful. My name is Madhav Sathe. I'm a customer engineering at Google Cloud. I focus on select FSI and banking customers. I joined Google around 2.5 years ago. Prior to that, I was with Deshaun at Pivotal and VMware. So I'm very excited to be here with Deshaun again and Abhinav, my partner in crime.
Abhinav.
Abhinav Rao. I'm a principal architect at Google Cloud. Similar to Madhav, I'm also in the financial select space, and I'm also an ex-pivot. So great to be here and happy to contribute to SpringOne. Excited.
What are we going to talk about today?
Well, we're going to talk about salsa.
What's
And salsa, it's the spice, it's sweet, it's delicious, but it is about software supply chain security. So I don't know whether you're able to see the screen.
I will add your screen. There we go.
All right. So the topic today, it takes two to salsa, and we are going to introduce a couple of technologies, Sigstore and Tekton, to secure your supply chain. We'll introduce the concepts and we'll go through some demos. So this is the agenda that we will have today. Why salsa and what is it? We'll go through a quick crash course on digital signatures, Sigstore ecosystem, and Tecton. And then I'll hand it over to Abhinav to do a deep dive into a demo of Sigstore and the Sigstore ecosystem. And then in the end, I will do a salsa demo with Tecton and binary authorization. So that's the plan. And
That's exciting.
Exciting, right?
We're going to have questions. Do you guys want to take the questions as we go, or should we save them till the end?
Actually, we will be happy because one person will be demoing and one person will be can answer the questions. So let the questions come in.
All right. Excellent. Well, let's go.
All right. So let's take first look at why salsa and what is it. Well, if you have built a software in the modern software supply chain way, then you will be familiar with this diagram that we are talking about here. You essentially have an automated build pipeline where on the left-hand side, there is a developer who is ingesting code in the code source repo. And some kind of an automated build process takes place, which goes through testing the code, verifying the code quality. At some point of time, maybe there are human beings involved to whether approve that code or not, or approve that build software package or not. And at the end of the day, your intention is to use that software somewhere, either hand it over as a dependency in another software, or build it as a package and then publish the package, or you essentially create an artifact such as container artifact and send it to deployment. In the process, you will end up using a lot of dependencies as well. So throughout the software supply chain or this automated process that takes the code from the left-hand side and hands it over to the right-hand side on the consumer, all of these are attack vectors. There are multiple points of attack vectors where the code can't be compromised. Even the build system can be compromised. The dependencies that you're using, they can be compromised. So essentially, what we are talking about here is that the package or the software that you're building may have vulnerabilities that you may not even be aware of. For example, the dependencies that you are using, they may be outdated, they may have vulnerabilities, or they may not even be from a trusted source. Unless there is some kind of authority to establish the dependency, to establish the build process, there is no way really to ensure that the build systems are not compromised. SolarWinds is a great example of the recent attack. What does it really mean in terms of the security of your enterprise? Well, the supply chain attacks are continuously increasing. There is a 650% increase in the OSS supply chain attacks. 70% of the Docker Hub images contains high or medium severity vulnerabilities. So the problem is increasing, and there are a variety of difficulties such as dependency confusion, typo squatting, malicious code injections. All of these are different ways your software can be corrupt. There is also a notice taken up by governments. This is security of the software, and the security of the software system is been now linked to the national security. And the executive order actually highlights that. Right now, it's a guideline that any software that gets deployed in the federal ecosystem should be signed and verifiable. The provenance should be verifiable. But eventually, it will become a mandate that any software should become verifiable and have a provenance that can be verified. So there is multiple reasons for enterprises to ensure that the entire software delivery system ecosystem is fully secure. That is where SLSA comes in. SLSA is not a tool or a solution. It is essentially a framework, and it stands for supply chain levels for software artifacts. And this website is given over here, salsa.dev. You can take a look at it. It is a cross-organization collaboration, a vendor-neutral collaboration. It's meant for improving the security of the software ecosystem for everyone. As you can see, VMware is one of the contributors, Google is contributors, and even enterprises are also contributing to it, like Citibank and Intel are also one of the contributors to that. The idea here is that it produces a checklist of standards and technical controls for enterprises to prevent tampering of the applications that you're deploying or the artifacts that you're deploying, improve the integrity of the artifact, and then harden the platform where the artifacts are built or the packages are built or software dependencies are built, right? That's a very high level purpose of SLSA. It's a framework, and it is backed by cross-organization support. Now we talk about software provenance. Essentially, the software provenance is giving you a metadata of any software, of how it was produced, where it was produced, and when it was produced. And it is to be done in a verifiable way. There is a little bit of a fun fact. We found out that the word provenance has an origin in perhaps a Sanskrit word pravara. In the ancient India, when people introduce themselves, they will introduce themselves with their parents' name, their grandparents' name, their great-grandparents' name, their village name. So essentially the full family history to establish the authenticity of that person. So it is exactly the same concept in software. If you're talking about a software provenance, you should be able to tell where it was built, which service built it, and what are the packages it contains when it was built, or what are the dependencies were used to build it. So with that in mind, let us take a look at what does SLSA kind of help you guide through enhancing security levels. There are 4 levels of maturity, right? And you can increasingly add more and more controls and standards in your process to get a higher and higher level of SLSA level of compliance. For example, most enterprises have started using scripted build and build services instead of having a manual build processes. But you can add more control on top of it, such as your build also can be written as code, and it can be version controlled, and the entire build can actually run in ephemeral environment, right? It can run in an isolated environment that will give you SLSA level 3. And more controls will give you SLSA level 4. So your objective should be to use this as a guideline to push your enterprise or push your customers or your people who give you software, right? Your people who give you dependencies, to push them for higher and higher level of SLSA maturity. Taking to the next part of the session, we'll do a quick overview of 3 concepts here: digital signatures, Sigstore, and Tecton. And we talk about digital signatures. I'll tell you why we talk about it. We talked about software supply chain, and since we are in Spring Boot, we all use Maven dependencies to build Spring Boot applications. How do we ensure that those Maven dependencies are coming from a trusted source, right? And
How do we do that?
Yeah, the only way you can actually ensure is to have a signature on it, so that some kind of a signature can actually ensure that this is coming from a trusted source and it has not been tampered with, right? And so that's what it is. So signatures essentially are a mechanism to establish the integrity of the software or a software package or a blob, right? Any change in the blob after the signed signature is generated will fail the signature verification. Even a single bit you change in the data, it will fail the signature verification, right? So at the time of signature, whatever is the data, if that data has been tampered with, then you can find out either that was tampered with or not. So integrity is one thing. Association of signer with a private key, that is also establish authenticity of who signed it, right? And non-repudiation, that once the digital signature is generated, the signer cannot say I didn't do it. Like, it has essentially a responsibility of the signer to ensure that the correct artifact is delivered. So that is essentially at a high level what is digital signature contains. Technically, let's take a look at what it is happening. So digital signatures use asymmetric keys, public key and private key. So it will use one of the multiple mechanisms available, schemes available to create these private keys or public keys. And the idea is that you have an artifact, software artifact, a file, or a container image, for example, since we're talking about software supply chain. So you use that container image and then use the private key to sign the container image. That will produce a signature. You attach that signature with the original artifact, and then artifact and that signature, you hand it over to the person who is going to use that software or use that software data. And then at the receiving end, you somehow find a way to deliver that public key uh, uh, along with the signature, so that the receiver of that software, or so somebody who is deploying the software, can verify whether that data was tampered or that artifact was tampered with.
So I
And
have a
that you can
question.
use with, yes.
Is this something that exists? Like if I'm going into Maven Central, are there dependencies out there that are providing this signature and this public key that I can go and verify with?
Oh, it's a great question. I don't know. Maybe. I don't know.
I mean, I believe Maven's already using
Hmm.
digital signatures now. I think Maven is one of the first, I think, that signed up for Sigstore, I believe. So we have to actually go in to check whether to verify. I don't know if any of the Mavens are verifying currently, but I know that they've put that in place. I think soon there will be things in place to verify as well.
Excellent. Thank you.
Yeah. Thanks, Abhinav. So this is a very high level architecture of how digital signatures is used. Now, if you look at it, the first question should arise is that how do you generate these keys? Then the second question is how do you safely secure the keys, right? The person who is signing the artifact, he or she needs to have a safe and secure mechanism of saving the keys, right? Some kind of a vault or some kind of an auto key generation mechanism where the keys are generated for you rather than you generating the keys manually. The other aspect is how do you distribute the keys? How do you distribute the keys in such a way that if the private key gets compromised or if the keys gets rotated, then you again have a way to distribute again and then revoke the keys that were already out there. So these are the challenges when it comes to key management, right? Distribution of the keys, storage of the keys, safe and secure storage of the keys. And what happens when there is a compromise of the keys? Like how do you easily rotate it? Let all the people who are using your software know that, hey, that key is no more in use, take this one. So that is the challenge, and that's perhaps where Sigstore actually comes in, because it offers something unique. It offers something that lets encrypt date for HTTPS or certificates used for HTTPS. So Sigstore aims to achieve the same thing for software signing and software provenance, what Let's Encrypt achieved for HTTPS or secure certificates, right? So that's the objective. This is the website of Sigstore. I think it's still under development. It is not yet And it's also a cross-industry collaboration, cross-organization collaboration that is contributing to this open source project. Now, why Sigstore? The important thing here is it's a fully open source stack, and it's also pluggable, right? You can take out the piece that where your enterprise has some standard already established, and you can use it. The important part here is it gives you an option of keyless signing. And what that means is we will, Abhinav will go in detail of what it is. It essentially gives you a identity certificate and temporary keys. It is used to create that, use OIDC to create identity certificate and associate the public key part of that key pair and with the certificate, and then use that certificate, short-lived certificate, to sign those software artifacts. It also has something called transparency lock, and Abhinav will talk about it, to verify the signatures. So at a very high level, this kind of covers the Sigstore, but Abhinav will go a lot more detail in that, and we'll have a demo as well. Let's talk about Tecton, which is other part of the puzzle here. Tecton is also an open source Kubernetes native CI/CD solution. For those at Pivotal or those who have used Pivotal extensively, or Pivotal software extensively, they will know Concourse, and it is seems to be very similar to it in terms of what it is able to do. The only difference is this is fully Kubernetes native. So CI/CD pipelines that are running, they are itself are Kubernetes resources. At a very high level constructs, we have something called as pipelines and tasks and steps. So step essentially is an operation that runs as a container. So you run a bunch of steps, and those bunch of steps actually form a task, right? And a collection of tasks you can have, and those will become your pipelines. And you can have like in sequence or in parallel task execution within a pipeline. So that's a very high level idea of what Tecton pipelines look like. Now, if you go a little deeper in terms of task run, then task run is an execution instance of a particular task. Pipeline run, similarly, is a specific execution of a CI/CD pipeline. So when you run a pipeline, it will also create a task run instance. It will use input and output resources to the pipeline run. So essentially, for example, if you're running a pipeline, you can use Git repository of your source code as input, and the output can be the image or image location where the image is pushed, right? So that's a simple example of what an input and output looks like. And since everything is running natively on Kubernetes, at the end of the day, it will use some kind of a file sharing mechanism like Workspace to pass on the input data from one task to the other, right? Or one step to the other. There is also a handy command line tool which will give you a higher level of abstraction. So instead of running a kubectl, you can run tkn, and in the whatever the current context you have of Kubernetes, it will give you the higher level of abstraction there. So when you run the pipeline, you can actually see the instances of the pipeline, and then you can see the output of that, logs of that, using the tkn command. Now, supply chain security. Tecton Chains is the supply chain security construct for Tecton pipeline. So there are Tecton has two aspects to it. Tecton pipelines, which is just a CI/CD tool, just like any other CI/CD tool, right? But Tecton Chains has a special aspect to it, that it actually watches your Tecton pipelines running, and it captures the results of that, or captures the snapshot of your task run, and then convert that into an attestation format such as in toto, which is what we will use in our demo in the end. It can use various mechanisms such as KMS, which is your typical cloud-based solutions for key management, or identity certificates to sign the artifacts that it catches. Whether it's, for example, in our case, it will sign the container image, and it will also create some kind of an attestation or provenance, and it will sign that as well. So Tecton Chains is like a native solution by Tecton to secure the supply chain executed by the Tecton pipelines. Well, that brings me to the end of the crash course. I will hand it over to. I think we are doing good on time, right, Dashawn?
Oh yeah, very good.
Yeah, cool.
All right, I'll switch over. That was great. I like. There's two things about that. Provenance. Hey, I'm Deshaun, son of Archie, born in North Dakota, etc. That same concept. That was a really good metaphor. And the other thing was the let's encrypt for HTTP comparison. Love it. Love it.
Yeah.
All right.
All right. Okay, it's my turn. So, so thanks, Madhav. Madhav talked about salsa at a high level, the framework, right? And then how we implement that framework, or how we conform to the framework, is using one tool, is Sigstore. And Sigstore specifically, to summarize, is for artifacts, right? And then the second part of that, is the build part, right? The build part, which is, when the software gets built, how do we make sure that that process is secure? So Tecton Chains handles that part of it. So let's go to a demo of Sigstore and see what that's all about, and then Madhav's going to take over and talk about how Tecton fits in, right, to secure the actual CI/CD process of when you actually build your artifacts. So Sigstore has 3 components, and at a high level, this is equivalent to, when we mapped it to Let's Encrypt. You can think of, I'm trying to map it to Let's Encrypt so people can sort of understand. So Fushio is, I know it's a mouthful, I'm not sure what it stands for, but that's the code signing CA that exists, and that gives you that keyless way to sign artifacts. Now, Fushio only comes into play when you are when you're doing a identity-based signing. So, for example, if you're an open source developer and you want to sign your artifact and you want to publish it to like a Maven repo, then that's when Fushio will come in to generate these temporary keys so that you can create a code signing certificate in order to sign your artifact. Then the next part is Recore. Recore is a transparency log that exists, and that's very much like the TLS log that's maintained, which whenever Let's Encrypt certificates are issued, it actually goes into a public certs TLS certs are issued, they go into a public transparency log, and you can actually go and look at that to see whether that certificate has been revoked. Very similarly, Recore provides that for artifacts. So if you have a public artifact that's going to be signed and you want to digitally sign it, then it gets recorded there. And then we'll see cosign at play in the demo, which is the other component, which is a utility to sign artifacts. So mainly it's used for container signing and verification, which is what we'll be doing today. But it can also sign blobs and things like that. But there are many, many other clients as well that can be used to sign Maven artifacts, Rust, Ruby gems, Python, etc. So it's not specifically for containers per se, but any kind of software artifact. And that's where cosign comes in. And the important part to note here is that each of these components are pluggable, in the sense that if you're in an enterprise setting, if you don't want to use Fushio, that's fine. If you just want to use transparency log, that's fine. If you don't want to use either of those and just cosign, that's also fine. So they're designed to be pluggable, but they can all work together as well. So at a high level, this is the path of how the Sigstore kind of flow chart works. So here, if you look at the life cycle of how things work, is that the developers on this side, they will use cosign to sign an artifact, and Fushio handles the aspect of signing it with a OIDC token. So that how Fushio works is that in order to sign an artifact with, if you're an individual developer, an open source developer, is you would interact with Fushio to create that OIDC flow. It will use that OIDC flow from your authentication provider, whether it's GitHub, Google, Microsoft, etc., and then it will generate a signing certificate that you can use, and that gets published in the Rekor transparency log, and that's an append-only log, and there is a public one that company called ChainGuard maintains, which you can use. So very similar to how Let's Encrypt provides a public service, ChainGuard is providing that for the public. But these things can also be deployed internally inside your firewall for an enterprise as well. So there's completely open source, pluggable components. So cosign is what we're seeing today, and we'll see some Rekor as well of how cosign can be used to sign an artifact, publish it to a repository, and then you can use Rekor to actually confirm or get a record of what was signed, and take a look at the full provenance of it. So this is a kind of a public record, and so this ensures that if, let's say, your keys get compromised, or you want to watch if somebody's using your keys, then this is a way. This is a place where you can watch and you can monitor whether what your keys are being used correctly or not. And the other key part of it is that if you're using the OIDC flow, it is creating temporary code signing certificates. So they're only alive for about 10 minutes, and the private key is in memory and never leaves cosign. So what this ensures is that even if the private key gets compromised, lifetime is very little. But what you do get is you get a transparency log in Rekor that says, well, I know when this was signed. So this is very important to know, to know when it was signed and who signed it. And this takes care of, the key sort of a compromise issue. So what are the different use cases are there for Sigstore? Is it only for open source developers? Is it also for other folks, etc.? So here we have three use cases. So the open source developer will use the OpenID flow for signing their artifacts. So that's the OpenID Connect, and that's using the Fushio stack. And then we also have other use cases where if you have a GPG cert or other things like a PKCS certificate, etc., you can use those as well to sign the artifacts. And then in the enterprise use cases, what we'll be looking at is how you can use a cloud KMS, and in our case, it'll be Google Cloud KMS, how that can be used to actually sign a container in an enterprise setting and then make sure it's being accepted inside a Kubernetes cluster. So at a high level, this is what the demo would do. So the demo is we're going to create a key over here in Google Cloud KMS, and we will use cosign cosign will use that key, reference that key in order to sign an artifact and upload it to Google Artifact Registry. And then we'll put a policy in a GKE Kubernetes cluster which restricts containers, so that it makes sure the containers that are signed by our a key in Google Cloud KMS, only those are allowed to be run in a particular namespace in this cluster. So there's a lot of pieces at work here. We've done some pre-work here. We created the key, etc. But we'll see the whole flow, how it's working. And then we'll see Rekor as well of how you can ensure that there is a public record of this happening. Well, not a public record, but You could run Recore at a private version of Recore. In our case, we'll be using the public one just for convenience. But just imagine you have a private version of Recore where any signing event that co-signing is doing is recorded, and you can have a monitor on that to ensure that those keys are always getting used correctly, so that whenever you don't see any unusual activity. So let's get to the demo. So here I've got some scripts, and this is Google Cloud, and I'm in a kind of a Visual Studio a shell and on the console, and I've got a Kubernetes cluster running. This GKE, and let's get started to sign our image. So the first thing we're going to do is we're going to run this script, which will set some environment variables, and then it's going to pull a Docker image. In this case, it's Nginx. So I don't have any images locally. So we're going to run this script, and what it's going to do is going to pull in Nginx, and then it's going to tag it with the artifact registry address that I have on GCP. So this is a private artifact registry that I've created, and then it's going to export that. It's going to push it there, and then it's going to get me the SHA, because that's going to be important for us to use in order to sign it. So we've got that. So if we do a echo SHA, we have the SHA right here. So let's go, and so the next step we have to do is let's go and get the let's go and see the key that we have. So let's take a look at the key. So this is a key I created beforehand, and it's just telling us that it's an asymmetric key, signing key, and it's using the ECC curve to 256, and that's it. And we'll be using this key for cosign is going to be using this key to sign the container. So I have this little script here that then signs the container, and we're using this little flag. I'll let you know what that flag is a little bit later. But the important part is that we're signing this, and we're pointing it to the key right here in KMS, the same address that I queried earlier. And then it's going to point to this container that we just uploaded in the previous step. It's going to sign that. So let's run this. So when we run this, it says, it appears to be a private repository. Please confirm uploading the transparency log at recore.sigstore.dev. So since this is just Nginx, I'm just going to say yes. And this is going to give us a T-log entry. So let's copy that right now, and then we'll store it away. We'll get back to it a little bit later. But let's just remember it. So we've signed it. We've pushed it. Let's take a look at our artifact registry. So here, I'm going to take a look, and now we have our container that was uploaded. And if we take a look, we actually have two different entries. One is for the actual image, and the other one is the actual signature that we uploaded, right? So you can see that those two artifacts are there in my private repo, and we've signed it. So how do we verify this thing? How do we verify that it's good? Well, we've got we've got to verify this. So let's verify it. So great. So this is telling us that the following checks were performed. Cosigned claims were validated. Existence of the claim that transparency log was verified offline, verified against the specific public key. So we have all the verifications that cosigned verify does. Now, this is all well and great. I can do it locally, but practically we need to enforce this in our cluster when this container runs. So how do we do that? Well, for how do we do that is we install the policy controller on our cluster, right? And we do that with this Helm. So I have this Helm command that's going to install it, and it's going to create a namespace called cosine system. So let's do that. And we'll install the controller. And it's going to also create the namespace if it doesn't exist. Great. Great, we got it. Now let's monitor the pods in that namespace, because make sure everything is running before we can before we do anything else. So it looks like it's still. Let's just do a -w on it and wait until all the pods are running. And then we can. Then what we'll do is we'll install a policy that will actually enforce that checking. So just installing the admission controller, it's good, but now we need to. So now that everything's running, let's install the image policy. So image policy, as everything Kubernetes, it's a Kubernetes object, and what we're doing here, it's called a cluster image policy object. And what we're doing is we're now pointing it to our key, right? And the important thing is what I did beforehand was I did install, I did create this cluster with a service account that only has read access to the public key, which is very important. The public key to KMS, right? So that it can verify it. So that's where this policy is going to come in. So let's apply this policy. So that's applied. And the next thing we need to do is we need to also create our namespace and then tag the namespace to saying that this namespace needs this policy enforced, right? Because you could have multiple namespaces, and each namespace you could have a different policy with a different key. So that flexibility you get. Let's do that. Let's label our namespace. Namespace is created. Great. So there's a moment of truth. So here, we're going to try to deploy that unsigned image into the namespace. So this should, if all goes well, this should get denied. Great. It's got denied. It's saying admission webhook policy denied the request.
It's a demo. What could possibly go wrong? I said, no pressure.
Yeah.
You got this.
Yeah. The next part is the crucial one, right? So now, so the denied. So this is what we want. This is great. Fantastic. So let's go to the next part. So now we're actually going to push the image that we created to the same namespace. So this should be allowed. Okay. And boom, created. So so that's allowed. So let's just make sure it's running. Make sure we're not doing any. Make sure. All right. Yeah, Nginx running. So that test worked. So I think all that practice paid off. Now let's go back to our notes, because we're still not done yet. So you remember how we had that T-log.
And the T-log, that's one of my questions. The T-log, that's the transparency log.
That's a transparency log. So they gave us an ID saying that, hey, I've created this transparency log ID. Now what I do is I go to record.tlog.dev, right? And I didn't see that, but I'm going to zoom in. And then here I can search by email. So this would be for like if you're doing OIDC flow and you want to check whether a particular person is attached to it. But for us, we did the enterprise flow, so we don't have a OIDC entry, but we do a log entry. So we go to log index, we paste it in, and now we see this was created 6 minutes ago, right? While we're doing this demo, and the entire entry is there, and you have the public key as well entry, and you have the verification proof that yes, this came from a cosine client at this time with a timestamp, etc. And this can be used to verify that signing event did take place, right? And it wasn't spoofed. And you can compare that with what's in your container registry as well for that. So this is kind of full circle where you have something. So this could be running in your own private enterprise, and you could publish it there. But we're just doing it to the public one just so that it's for convenience.
Mm-hmm.
So
that was great.
So that was my demo, and I'm going to hand it back to Madhav to do the Tecton demo.
That was great. I have one more question.
Sure.
This idea of maybe what I'm delivering has multiple layers in its image.
Yep.
Each layer is going to get that same signature, and I can validate each layer separately before I validate the entire thing. Is that the idea?
That's the idea. So when you're building your container, let's say you are your Docker image, you have a Docker file, and you say from block layer, this layer. They're still building out that infrastructure in order to be able to say only include it if it's been signed, only include it if it's been signed, and so on and so on. So we're getting there slowly for containers, but that base layer has to come from a trusted source, and so that has to be in the Rekor public repository. So you could have conditions where if your build system supports it, you could say enforce building only, make sure that this base image is signed by this public key or this developer, etc. And you can then go down the line and you can enforce that in your build system. That's where Sigstore is going, and all the tooling vendors, everybody else is going.
Excellent, wonderful. Madhav.
Yep.
Wrap it up. Let's bring it home.
Yep. Can we switch to my screen? I think we're still.
Oh, sorry about that. There we go.
Yeah. All right. So thank you, Abhinav, for a wonderful demo or deep dive demo of Sigstore and patiently and explaining all the concepts. Now what we'll do is we'll use Tecton and binary authorization put together, where we'll use the GCP stack. And let's understand all the components that we have used in this demo. On the left-hand side, we'll use the GCP specific components. On the right-hand side, we have open source components. There is no surprise, we're going to use GKE for creating the clusters, and IAM for identity management and workload identity to go with it, to make sure that the secure, keyless, passwordless access to the GCP resources. We'll use KMS just like you use, Abhinav. We'll use KMS to create asymmetric keys, artifact registry as a Docker registry. Binary authorization is a unique feature provided natively by GCP for securing your supply chain by ensuring that only trusted artifacts can be deployed either on GKE or Cloud Run, which is the serverless environment. So binary authorization is a native support what some of the Sigstore attempts to do. It's fully integrated with the product line. On the right-hand side, we'll use Kaneko as a mechanism of building container image. You don't have to use Kaneko. You can use whatever the mechanism you like. For example, Cloud Native Build Packs is a perfectly good example of container build process. Pipelines, Tecton pipelines are used as a CI tool in this case. And we'll use Tecton chains as slightly described earlier. We'll go through the details of that now. But Tecton chains essentially to create that signatures in an automated fashion without imperative commands, right? We want to automate everything in such a way that the CI pipeline will just do what it's supposed to do, which is build an application, create a container image, and push the container image to the registry. And upon doing so, Tecton chains will then kick in and automatically create the signatures, create the provenance, and sign the attestations. So Tecton chains automates that process. We use the Grapheus DryDoc as a container analysis API, and Tecton chains gives us ability to configure what backend to use for container analysis API, what attestation format to use, what is the mechanism to create signatures, whether it is a KMS or X509 certificate. So what is the source from which you're going to get your keys? So Tecton chains give you the config map to actually configure those parameters. Cosign is a tool that will use only CLI in this case to verify an image from the CLI, but automation is done via like this. Let's take a look at the architecture of what we are trying to demo. And we believe this architecture can get you from salsa level 2, salsa level 2 plus, I think close to salsa level 3. We'll talk about that now. Now, it's little involved here. The diagram will explain it slowly. On the left-hand side, you have a Tecton, a cluster, a GKE cluster that runs your Tecton stack, primarily your Tecton CI pipeline, which is being watched by the Tecton chains, right? Just like any other CI pipeline, it is going to read the source code. Whenever you git push the code or merge your code, it is going to read the code, go through the build process, which involves your testing and so on, and then eventually create a container image that will be published to the artifact registry. Artifact registry is GCP's native container registry, and it gives you a dry dock Grapheus API for container analysis information. So Tecton pipelines imperatively pushes the image there. However, Tecton chain is watching the Tecton pipeline task runs or pipeline runs. Upon completion of this image creation process, the Tecton chains will read the image digest and the location of that image, right? And then essentially it also watches which task run created that image, and it has the information of the image and the task run that created the image, and uses that information and the keys that are created as a private key pair. It will use that key to then publish the image artifacts, such as digital signature of the image. It will be published on the artifact registry using the Grapheus and dry dock API, as well as it will create an attestation, sign the attestation, and publish that to the artifact registry as well. Now, why this? It uses the Kubernetes service accounts, and those are mapped to, using the workload identity, those are mapped to IAM, which is a Google service accounts, Google Cloud service accounts. So thanks to that, the interaction between the Tecton chain and the rest of the ecosystem is keyless, passwordless, and purely done through the IAM. So it has the permission, this identity, this IAM identity has a permission to write to the artifact registry, get the KMS key, and get a retrieve a signature from it, etc. So this is your CI process, which is essentially publishing an image, and Tecton chains, which is watching that, is gonna publish these provenance and the digital signatures. On the right hand side, I have another GKE cluster, which is your application cluster, and you can secure it the way you like it. The idea here is that you're eventually going to deploy a deployment or a pod, but we are introducing binary authorization, which is enabled on this GKE cluster. Now, thanks to the binary authorization, it is also a policy admission controller, and it works with something called an attester. Attester uses the public key to verify the image signatures and the attestation signatures. So binary authorization, you can write a policy that will allow or deny initiation of a pod, right? And that essentially gives you the mechanism to have a cluster-wide policy definition. So what you can do is, when your application artifact or image goes from lower environments to higher environments, it can gather more and more attestations through the process. For example, when you build it, the image, the first hand, it will just make sure that the image has certain, it has passes through the CVE check, for example. Then it will have one attestation. Then a QA engineer will go and test the application and then manually approve the quality of the application. Then it will give another attestation. Or you may have automated test pipeline that will go ahead and perform some automated tests or performance test, and that will also add another attestations. So you can accumulate these attestations as your image is traveling from the lower side to the higher side and eventually reaching the production, or moving from lower environment to higher environment. And the binary authorization on each of your GK cluster can have a policy that will list out the attesters, essentially list out the attesters that need to be present for the image in order to get deployed on that particular cluster. So it's just not just one particular thing. You can have one or more attesters accumulated through the process. Now, as you can see here on the left-hand side, this Tecton chain becomes your signer. So it uses the private key. And the binary authorization attester becomes your, essentially uses the public key to verify the artifacts user. Both of them use the Grapheus DryDoc API. Binary authorization uses that, as well as Tecton just natively supports that. By the way, I didn't have to do anything extra to get the DryDoc API running on the artifact registry. It natively supports the Grapheus DryDoc API for container analysis. All right. So just a little bit on workload identity. We talked about these two Tecton pipeline as well as Tecton chains with their respective Kubernetes service accounts, which are matched to respective identity accounts or GSA with using the workload identity maps. And they have respective permissions for least privileges, right? So this one, the workload KSA usually gets the Tecton to push an image to the registry, and the Tecton chains controller KSA will give access to KMS keys as well as write to the DryDoc API. So with that, I'm now going to switch gears and do the demo, quick demo. All right. So let me quickly walk through the environment. I have these two clusters already created and deployed. I'm not going to walk through the process of installing binary authorization or creating the policies. I already have the cluster created here. One is a Tecton cluster, which is where the Tecton pipeline and Tecton chains run. And other is the workload cluster, which is where my application is going to run. These are the applications that are currently deployed on the clusters, as you will see. This will be a binary authorization. In case of binary authorization, as you can see, I have already added an attester, and that attester essentially will tell the binary authorization for the cluster, my workload cluster, it is running on a workload cluster, that any image that doesn't have this attester will be declined, and we'll verify that, right? So image that doesn't have this attester will be declined, and image that has the attester will be allowed to be deployed. This is my artifact registry where all my artifacts will be published. So once I execute the Tecton CI process, which I'm going to invoke manually, it will create a new image here. And there are three entries here, the original image, the digital signature of the image, and the attestation, the signed attestation of that image. The attestation includes essentially the build, the snapshot of the task run, which creates that image, right? And this is a typical image signature. So let's go ahead and do that first part. I'm going to, I hope the screen is visible properly. I'm first going to create the image. So I'm invoking the Kaneko-based pipeline, which will read the source code and then create the image, container image. All right, live demo. Okay, let's see.
That's absolutely okay. We know that this happens. You keep on going. I'd like to say hi to everybody that's joining from around the globe. We have folks from India, including Chennai. This has been great. I don't have envy. I'm not jealous at all of your pipelines. This is something that I'm definitely missing. I need to add. I like this idea of maturity model that says, hey, like we're moving. I've got some targets. I've got things that I can work towards with these different levels with Salsa. So this has been a powerful session already. I do have a couple of questions. Maybe Abhinav, maybe you can help me while we're waiting. Hello from Meadow from France. The multiple multiple clusters approach. Is that required? Like, do I have to do this in different clusters, or can I do this all in the same one? I like it. I see what's going on. It makes sense that I'm building things, but I don't have to do it that way, right? I can do this all in one cluster. Is that okay?
Yeah, you could do it all in one cluster, sure. But usually, I mean, for a demo, yeah, absolutely. But usually in practice, most likely you would have your cluster that builds your images is going to be different than cluster that runs your images, right? So, yeah.
Wonderful. All right, it looks like Madav, how's it going?
Well, I thought my environment was ready. It was not.
That's okay.
So,
I've got another
that
question while we
was-
see if that's
yeah.
coming. Can I do this same process for things outside of OCI images?
You mean
something similar?
you mean for Sigstore or for Tecton?
Sigstore.
Yes, yeah. Sigstore, you can sign pretty much anything, any blob, like npm, Node.js libraries, Maven. If that's if God forbid, if Windows executables is your style, yeah, absolutely, go ahead.
We don't judge here. We don't judge. Like, if that's
Yeah,
the thing.
absolutely. .NET, absolutely. I mean, it's just that you have to have the support of whatever runtime that you're using to enforce that, right? You could sign anything you want, but if your OS is not going to have the support, so I think soon, hopefully with this, because it's still in a very early stage, it's not GA, right? So if the operating system makers, the JVM makers, the app, if Kubernetes obviously has support for the policies and so on, but your runtime, whatever is going to be executing your code, there needs to be some enforcement mechanism as well.
Yeah, it doesn't have to, this isn't just for Kubernetes. I can take this and do this verification outside of Kubernetes. It doesn't have to be a policy controller or anything like that. I can do this outside, just following those same blocks, right?
Yeah. You could sign a blob. Absolutely, you could sign a blob of some kind anywhere, but then and then verify it before you want to run it, right? I think we're all used to in the Unix world. Whenever we download and run stuff, you're like, oh, check the SHA or MD5 hash of this thing, right? Or whatever. So I think soon it's going to be, check. There's going to be a instead of doing that, you will be doing maybe a cosign verify, or some flavor like that to say, hey, do this before you run it. Of course, we've had code signing, in Windows apps and Windows drivers and all kinds of other things, obviously, but they're very, specific to the vendor or specific to this. This is more democratizing it. What Let's Encrypt is, again, the analogy, right? For the masses, for any sort of artifact.
And last question for me before I
let me
hand it back.
a demo.
Go ahead,
Sorry,
Madav.
go ahead, Deshaun.
No, you go. You finish.
Okay.
I got questions.
So what I've done so far is I've run the CI pipeline, which creates an artifact, and so artifact was created by Kaneko. This is the container image that was created just now. But the Tecton chains, which is watching that CI pipeline run, that captures the snapshot of task run or the pipeline run execution context. It signs that task run to create an attestation, signed attestation. So this .att, that is the signed attestation that you see, and .sig is the signature of that container image that got created. Those two artifacts are automatically generated by Tecton chains by simply watching the Tecton pipeline create the base, the application image. What we're going to do next is going to use the CLI to verify the provenance. So we'll verify the two things. One, verify the signature, and then verify the attestation. So we'll quickly verify the two. We'll first pull down the image, and it is going to verify that the provenance of that image is okay, that the image we just called a dry doc API, verify the signature, and it looks okay. Then we're going to investigate the attestation that was created, the ATT aspect of it. And that attestation also seems to be okay. But that was just a CLI. Now I've installed the binary authorization policy, similar to what policy controller from Sigstore. The binary authorization has a policy which will deny anything that doesn't have the attestations to it. So now let's go ahead and do that. we already have the authorizations created there. What we're going to do is open the application here. And first I'm going to run both through because it has the full context.
And if anybody's got questions, get your questions in now. We're going to be wrapping up shortly, and we'll have time for some Q&A.
Yeah, this is pretty much the last part of my demo. I will deploy the workload, which has two parts to it. One is a trusted image, another one is an untrusted image. And it will decline the untrusted image and accept the trusted image. We'll verify both. So what happened is that the application not allowed, which is the public Nginx image, I tried to deploy it like this, and it did not work, right? Although it says the deployment was created, you will see that the list of events highlight that the image was not attested and the pod creation actually failed. So if you list the pods, you will not actually see any resources there. But now we'll go ahead and deploy the trusted image, and the trusted image has the required attestation and it is already running in the container. So now if you just do kubectl get pods, you will not see the non-allowed container image there. As you can see, we try to deploy both the Nginx image in the same context, same cluster context, and the trusted image in the same cluster context, essentially. This one went through fine, and this one did not. And excellent. All of that is through the binary authorization, which is the native support of that.
Nice.
So good.
So good. I wish we had the confetti effect whenever the demo goes well.
Right.
Yeah.
We'll do that. We'll do that post process.
Policy. Yeah. Well, recovering from a failed demo is should have a special.
Yeah, we made it. The thing is, we got to see you recovering from your demo. We saw what was going on. We get it. Sometimes that's when we learn the most. That's why I'm never afraid to mess up a demo. I think there's a lot of value in knowing that, hey, no matter what happens, we can always recover. Sometimes it just takes a second. And a lot of times that's where the learning really happens, when the demo doesn't go the way it's supposed to go. Guys, I want to say thank you. I want to say thank you to everybody in the audience. This was great. It's given me a lot of things to think about. There was one question that I wanted to ask. I'm going to try to do it real quick. The different key per namespace. On my policies, do I have to have a different key per namespace, or can I have...
No, different. Yeah, as long as you label it. You can label multiple namespaces with the same key, as long as you have your image policy set. Yeah, image policy, you can have multiple image policies, but you point an image policy to a namespace, so you could point the same image policy to multiple namespaces.
Excellent. Excellent.
By the way, we wanted to thank one of our ex-colleagues, Veer Muchandi, who had helped us build this, because this space is still evolving.
Yes.
There are hardly any places where you will find a consolidated demos of everything put together, of Tecton chains with fully working binary authorization or Sigstore and everything. So this ecosystem is still evolving, and through this we will. One lesson that I would share is that when we're doing this Tecton demo, Tecton chains, Tecton is also evolving. And what I found out was the demo that I had built 3 months ago, that didn't work in the morning when I tested it, because the versions had changed and the background didn't actually work. I mean, the backward compatibility wasn't there. So it's one of the things that if you're using Tecton in production, beware of the version compatibility issues.
Wonderful. Thanks. Abhinav had to jump. I wanted to let you finish. This is great. This has been great. I want to circle back. I want to pair up again soon, and I want to show you a demo. I want to take my code through this, and I want to circle back as this continues to mature.
Wonderful.
Thank you so much for joining.
Deshaun.
Thanks for joining. And there's more, right? Yep. We're not done here. The golden path to SpringOne is still going to continue next week. We hope to see everybody back. But until then, enjoy.
Bye-bye.
Thanks.
Thanks.
Yeah.